Hello again, everyone. Welcome to our discussion of section 1.5, where we will talk about a variety of very important topics. In fact, you're seeing a list of them on the screen right now. So the zero product property is basically saying, that if you have two things being multiplied, and if they're equal to 0, then either A is equal to 0 or B equals to 0. Okay, so if that's the case, then either A is equal to 0 or B is equal to 0, or both of them are equal to 0. This is very helpful property when we set equations equal to 0, and then we solve for factors of those equations, or for the variable in that equation. The square root property is another very useful property. It says that if you have a term such as c squared equals a, then that is, if you take the square root of both, or x, let's make that x squared equals a, then when you take the square root of both sides to solve for x, you will get x equals plus and minus square root of a. So you don't just get positive square root of a, it's plus or minus. Both answers squared lead to x squared. Okay, so the quadratic formula, you've seen this before. It is equal to, usually when a quadratic equation is not factorable, then it's called a prime quadratic equation. To solve a prime quadratic equation, we usually use a quadratic formula. And the quadratic formula is as follows. I know you've seen this before, so this will be a reminder or a review. B squared minus 4ac over 2a. We'll use this formula to solve for x when the quadratic formula cannot be factored. And the discriminant and its properties. The discriminant is the inside of the radical expression in the quadratic formula. So in other words, this is the discriminant is that piece that is equal to b squared minus 4ac. That's called the discriminant, just that piece. Not the square root, just the piece in the radicand, or the inside the radical expression. Then the solving literal equations, that's another topic in this section. The literal equations are equations with multiple variables. So instead of having just x, you have x, y, z, m, n, and you're solving for m in terms of the other variables. Those are called literal equations. So we will look at those. Solving quadratic equations by completing the square. This is a very, very important method, especially for those of you who will be taking, not only for those of you who are taking this class now, but those of you who will be taking trigonometry next semester, you will be using this method a lot. It's a very useful method especially for solving equations of what we call conic sections. Conic sections being circle, which is the figure that we will look at in this class, and also the ellipse, the hyperbola, and the parabola. For all of those, this method can be very useful. And solving equations in general, we will look at that. Solving equations with one radical expression, and solving equations with two radical expressions, and solving absolute value equations. Okay, so as you can see, this is a very, very important section. So one thing I want to remind you before we start going over all these topics and examples of these topics is that please remember how to study mathematics or any quantitative subject. We've been talking about this. First, before I cover it in these videos, or before you watch these videos or come to class, skim through the textbook section on the topic. You should not spend more than an hour, preferably between about half an hour to 45 minutes, skimming through this section, reading through it, just to get a feel for what it's talking about. Then, attend each class section or each class lecture and take careful notes that are useful to you, because each of you is an individual, so each of you will prefer or need a different part of the lectures in class. Some of you might know most of it, and some of you might take just 10% notes. Some of you might take 90% notes. So those notes will be helpful to you. And also you'll have the chance to ask your questions right away in class. And then review your lecture notes and solve all the problems your teacher solved in class without looking at the solutions. This goes for the examples, for the solved examples you see in the book as well. And complete all homework assignments by the due date, because they are timed so you can do your optimum best on each exam and learn the material gradually rather than procrastinating and trying to get all of it done at once, which is not very helpful at all. And of course, as you go through this course, review the sections from the past as well as the sections that were just covered maybe the week before. Okay, so having said that, let's discuss these topics. So this is what we talked when I mentioned the zero product property. When you have two products, the product of two terms equaling zero, whether it's one term multiplied by another one term or two terms multiplying by each other like that, two terms multiplied by another two terms equaling zero, then either A is equal to zero, which is causing that whole product to be zero, or B is equal to zero, or both A and B are equal to zero. Okay, like I said, this property is very important when we solve equations that are set to zero. This is the same property as that, but instead of one term, we have two terms. So we set, if the product of these two parentheses is equal to zero, then we set each parenthesis equal to zero, then either x minus a equals to zero, or x minus b equals to zero, or both of them are equal to zero. And we do that in order to solve for x from each parenthesis. Okay, square root property is when you have x squared equaling some value, then to solve for x, you'll have to take the square root of both sides, right? So when you do that, the other side ends up with, so x ends up with having two solutions, not one. That is plus or minus square root of c. The quadratic formula, we use this. So you can, first of all, you can use this anytime. It doesn't matter if a quadratic equation can be factored or not. One of the best uses of this is when you program a calculator or a computer software to calculate quadratic equations, solutions of quadratic equations for you. So it's a very important part of programming, can be an important part of programming. But in our class, specifically, we will have use for this if factoring and solving the quadratic equation by factoring does not work. Okay, and in which case we call those quadratic equations prime quadratic equations. Prime quadratic equations are quadratic equations that cannot be factored. Now, with respect to quadratic formula, I'm sure you've seen this a lot. But this piece, the piece inside the radical, not the radical, just that piece, b squared minus 4ac, that piece is called the discriminant. It has a name, and the discriminant has properties. So the properties of the discriminant are as follows. If the discriminant, which is b squared minus 4ac, is some value, some positive value, or greater than 0, then we know, without solving the quadratic equation, we can predict that the quadratic function has two real solutions. Real, by real we mean real number solutions. If that discriminant is positive, that's the case. If the discriminant, or b squared minus 4ac, equals 0, then the quadratic function has one real solution, just one. The second one, because it's a quadratic equation, because x is squared, so it must have two solutions. So if the discriminant is equal to 0, only one of those two solutions is a real solution, which is the main focus of this course. We will talk about complex numbers as well, but that will be just one section. Those of you who will be majoring in computer science or electrical engineering or computer engineering will use complex numbers extensively in the subsequent math courses that you will take. But in this course, we just have one section on complex numbers. So if the discriminant is less than 0, so we've talked about what happens if the discriminant is greater than 0 or something positive. What happens if it's 0? If the discriminant is less than 0, then the quadratic function has complex solutions. In other words, it has no real number solutions. Both solutions are complex numbers. If the discriminant is a perfect square, such as 4, 9, 16, 36, 49, and so on, then the quadratic function is factorable. So that's a very useful way of determining whether a quadratic function has factors or not, because you don't want to look for factors if none exists. So this is just, you can take a look at the discriminant, calculate the value. If it's some value that is a perfect square, then you know the quadratic function is factorable. Okay, so we will use all these properties and statements throughout this section. But for now, let's start by solving literal equations. Literal equations, these are equations with multiple variables, like you can see here, r, r1, r2. So you got three variables here, multiple variables. Okay, when we solve the literal equations, we can be asked to solve for any of the variables, r, r1, r2. But once it's specified for which one we are solving, then the other variables in the literal equations are considered to be a constant value. Okay, as long as we have not specified what variable we're solving, all three are considered variables. But as soon as, for example, in this case, we're asked to solve the literal equation for R1, then R and R2 become constants, like 2, 5, negative 8, 5 halves, something like that. Okay, so now to solve for R1 in this case, one thing that none of us like, and they make things complicated, are these fractions. So the first thing to do is get rid of all fractions at once. One of the most common errors that I see is that people try to eliminate fractions one at a time. We cannot do that. We want to multiply both sides of an equation by a single term such that it would clear all fractions at once, not by one. So to do that, then we multiply both sides of this by r, r1, r2. Okay, that's one term that is a product of three terms. Multiply both sides by that, so r, r1, r2 times 1 over r equals r1 r2 times 1 over r1 plus 1 over r2. So I've seen many times people multiply this side by r to get rid of r and multiply this one by r1 and this one by r2. That's totally wrong. Again, to clear all fractions in a single equations must be cleared at once by one term, not by different terms. So this is one term. R1, R2 is just one product term. Because you see them as three different terms because there's no value there. If you had 2, 3, and 5, you'd have 30, just one term. But because these are just variables, then you see them as different terms. But it's this whole three terms product is one term when we multiply both sides by it. Okay, so now let's simplify. Let's distribute and simplify. On the left, we already have distributed. We already have one this and another fraction. So we know that this r and this r cancel each other out, and we end up with r1, r2, right? The fraction is gone. On the right-hand side, I strongly encourage you to distribute first, then simplify. Don't distribute and simplify at the same time. I've seen many people try to do that, to combine two things at once, and they make many, many errors. So to avoid errors, do one thing at a time, as I'm showing. So first, I'm going to distribute r1, r2 times 1 over r1 plus r1, r2. We're distributing, right? This multiplied by that, this multiplied by that, times 1 over r2. Okay, so now let's start simplifying. After we distribute, let's start simplifying. So r1, r2 is equal to r1 and r1 cancel out. We end up with r times r2 plus. In here, r2 and r2 cancel out. We end up with r times r1, right? So the fractions are all gone. We have just one equation with no fractions. Now they're asking us to solve for r1. That means we need to isolate r1. Anytime you're asked to solve for any variable, it means you need to isolate that variable. Okay, to isolate r1, because we're solving for it, take a look. r1 appears in two spots. We need to bring these two terms that have r1 in them to one side. We need to take steps in the direction of isolating r1. And to put all the terms that have r1 in them on one side is one step in that direction. So I will write r1, r2. I'm going to move this r1 to the left. It was positive. When I move it to the left of the equality symbol, it becomes negative. r1 equals r2. Now take a look at this equation. We have brought both terms that have r1 in them, which is the variable we're solving for, to one side. Now we need to isolate r1 even more. How are we going to do that? Well, we need to factor r1. That's the only way to remove r1 from two terms. So let's do that here. Factor r1. Then what should we have here such that if r1 is distributed to it, we get r1, r2? Well, r2, right? r1, r2 is r1, r2. So minus, what should we place here such that if we multiply r1 by it, we get r1? Well, r, right? So we factored R1 out. Remember, we're solving for R1, so everything we do, we should isolate R1 further and further until the last step. So that is equal to R2. Now the last step. How can we solve for R1? Well, divide both sides by R2 minus R, right? We're going to solve for R1, so we're going to have to isolate it. So therefore, R1 is equal to R times R2 divided by R2 minus R. So solving for R1 means isolating R1. It's always like that. When you solve for any variable, that means you must isolate it. Okay, so we have R1 equals that expression. Can we simplify that anymore? No. There's nothing else we can do to simplify. If we could, we would simplify the final answer to the extent that is possible. Here's another literal equation. We have this equation, V, capital V, equals 1/3 pi r squared h for r. Okay, so our objective is to solve for r, not r squared, r. Okay, once again, take a look at this. We have a fraction, right? No one likes fractions because they complicate things. So let's get rid of the fraction by multiplying both sides by a single term or value. What would that be? How can we get rid of 1/3 on the right? Well, we have to multiply both sides of the equation by 3. So 3 times the left-hand side, which is just V, equals 3 times 1/3 pi r squared h on the right. Okay, so we know that the left-hand side is simply 3v. The right-hand side, because everything is being multiplied, there is no plus or minus here. So there is only one term, one big term, into which we have to multiply 3. But that term has a denominator 3. So that and that cancel out. That denominator belongs to all of that. Okay? So instead, we end up with pi r squared h. Okay? So we're solving for r. We need to, for now, isolate the r squared term. Okay? How can we do that? For now, pi and h are being multiplied by r squared. So let's divide both sides by pi h. Pi h. What do we end up with? We end up with, on the left, we have 3v over pi h equals r squared. We're not done, right? Because we're solving for r, not r squared. Okay, so let's come up here. Then r, we can rewrite this so it's visually looks more proper. So this, I'm not going to solve anything yet. I'm just going to swap these so they look the way I think it would be better. So the unknown on the left, I guess this is my habit. Whenever I solve some equation for a variable, I'd like to put the variable for which I'm solving on the left. It's probably a habit. So 3v over pi h. Now we're solving for r, so we have to take the square root of both sides, right? Square root of r squared equals square root of 3v divided by pi h. So what I've done has an error in it. Do you know where the error is? Do you see it? Well, let me bring this back. Remember, we talked about square root property. Every time you have something squared equals c, if you're solving for the side that has a squared, then the other side gets plus or minus. So what I need to do is just add plus or minus. Now that is correct. Okay, and this is just mirrored ink. Okay, so on the left, we have just r. On the right, we have plus or minus square root of 3v over pi h. And that is the final answer for us. Okay. Sometimes when you have plus or minus answer, the problem asks you to just accept the positive one, in which case you toss out the negative and you keep and accept the positive solution. Okay. Completing the square, or solving the following equations by completing the square. Let me just, I think that's, I should have clarified that. The method of completing the square is only used with quadratic equations. Okay? Completing the square, let me add that here. This method can be used only with quadratic, which is that. That's a quadratic equation. Why? Because the highest x power is x squared. Okay, quadratic equations. All right, so for us to use the method of completing the square, the coefficient of the quadratic term, which is the x squared term, must be positive 1. It must be, otherwise we cannot use the method. So in this case, it's a 3. Let me add a note here. Note. Completing the square can be used only when the coefficient of the quadratic term x squared is positive 1. Is it positive 1? No, it's positive 3. So what do we have to do to make it positive 1? We're going to factor it out. We're going to factor 3 from x squared and minus 6x. So let's do that. So we can apply the completing of the square method. So 3 times x squared minus 2x minus 1 equals 0. Okay? So now I want to move the negative 1 to the other side. So 3 times x squared minus 2x equals 1. Right? So now, how do I complete this square here? Once you have the quadratic equation with the coefficient of the quadratic term equal positive 1, then take a look at the x term. This is b, right? We know that this is ax squared plus or minus plus bx plus c, right? That's the general equation of a quadratic equation. So this b term, we call the coefficient of the x term b. Whatever that is, divided by 2. Always divided by 2. Whatever it is, if it's 7, if it's 9, if it's 10,000, divided by 2. So this one, negative 2 divided by 2 is equal to negative 1. Whatever the result, we're going to put that in the parentheses squared and complete this square. So 3 times x minus 1, right? X, no squared, x minus 1. I said whatever it is, when you divide b by 2, whatever you end up with, put it here. If it's positive 1, this would be plus 1, x plus 1. If it's negative 1, minus 1. Squared equals 1. Right? So now we've solved one problem and we've created another problem. So let's see why I say that. See, we've solved one problem because we've been able to put these two terms as part of a complete square. X minus 1 squared is a complete square. Right? It's two terms squared. But the issue that we created is that if you expand this, you don't end up with just x squared minus 2x. You end up with positive 1. So let's do that. So if you expand this, you will end up with positive 1 as well. So 3 times, I'm going to expand this, x squared minus 2x, and I'm using the special product formulas we learned last time. You can FOIL it, but if you remember those special product formulas, you'll do this quicker and easier. Plus 1, right? And on the other side, of course, we have 1. So all of this, what you see in this bracket, is this, x minus 1 squared. Now compare this whole equation, with what we started with that one, before we completed this square. Are they the same? 1 and 1 are the same. 3 and 3 are the same. But if you compare inside the parentheses with this, we have an extra 1. Right? We have an extra 1. So what do we need to do to balance this, to make it look like that? We need to subtract 1. Okay? So now, let's see. So actually, because I put the, since I put the negative 1, since I have a 3 here, so what happens is that this 3 multiplies this 1 by 3, so we actually have to subtract 3. But instead of doing that, let me do this. Let me put a brace here. So I'm going to put a brace here. So now we're good. Okay, so now this 3 multiplies itself by this, becomes positive 3, then multiplies this by negative 1 by 3, it becomes negative 3. Negative 3 plus 3 add up to 0, which they should. Okay, that's what we want to do. We want to eliminate this extra third term we always produce when we complete this square. When you complete this square, you always generate this third term, which you don't need. So you need to eliminate that third term. In this case, that's how we're going to eliminate it. And I put the braces, curly braces, around the outside of this so that now, because we have a 3 out here, so 3 multiplied by this positive 1 will make it positive 3. Then we need a minus 3 to balance it. So 3 times minus 1 is minus 3, and it'll work out. So let's distribute. So let's rewrite this. So now we can rewrite this in complete squared format after distributing the 3. So we have 3 times x minus 1 squared minus 3 equals 1. Notice all I did was because this is the expansion of the completed squared here. So I rewrote this over there, except that I subtract, after distributing the 3 into this, you end up with a minus 3, which is what we want. Because if you expand this, you get positive 1 times 3, it's positive 3. We don't need that, so subtract 3, and we add up with no 3, or add up to 0, which is what we want. We end up with the 2 terms that we started with. Okay, So now we have x minus 1 squared equals to, let's move that to the other side, and it'll be 1 plus 3, or 4. Okay. So now to solve for, now we can divide both sides by 3, right? Because we're still solving for x, but we're using completing the square method to achieve that, because that was specified for us. Okay, we were asked to not to use a quadratic formula or factoring. We were asked to use the completing the square, and this is just to demonstrate to you how this method works, because in trigonometry and in conic sections, then you'll need this. Okay, so x minus 1 squared is equal to 4/3, and then we're solving for x, so we need to isolate x, and so that will be, take the square root of both sides, we get x minus 1 equals plus or minus square root of 4/3, right? And then this will be x minus 1 equals plus or minus 2 over square root of 3. If we rationalize the denominator, we know how to do that, right? If we rationalize the denominator, so we get 2 square root of 3 over 3. So x minus 1 equals plus or minus 2 square root of 3 over 3. That's just to rationalize the denominator. Multiply the numerator and the denominator by square root of 3, and we end up with 2 square root of 3 over 3. Now one last step to solve for x is just move this negative 1 to the other side. It'll be positive. So we have x equals positive 1 after we move it, plus or minus 2 square root of 3 over 3. And that's the solution of x. Okay? So that is the completing of the square method. The important thing was, remember that in order to apply this method, the coefficient of the quadratic term must be positive 1. In this case, it wasn't. So we had to factor the 3 out. Once we had the coefficient of the quadratic term positive 1, then we could apply the method, and that's what we have there. Okay, let's do another example of this kind. This time, once again, the coefficient of the quadratic term is not positive 1. So we need to factor out 2. Right? So let's do that. I'm reminding you guys to please pause the video, apply the method to this, completing the square method to this, before you watch the rest of the video. Okay, I'm assuming you've done that and you're back. So and I'm hoping that my solution agrees with your solution, which means you're doing great. Or both of us are doing great, right? So factoring out 2, we have x squared plus 4x plus, plus 1 equals 0, right? So now we have the quadratic term has a coefficient positive 1, right? So now we can complete the square here. Notice that the b term is 4, right? So divide 4, whatever it is, by 2. You end up with positive 2, right? Okay, so to complete this square, we write 2 times x plus 2. That plus 2 is that. plus 2 squared, then this positive 1, I want to send it to the other side, equals, well, let me do that in the next step. But for now, so equals negative 1. That negative 1 is that 1, which I have sent to the other side. Okay, so now, just like the previous example, we've solved one problem, which is complete this square, but we've generated another problem. So what problem did we generate? Well, we've introduced a third term, which we don't have. We only have 2 terms. But if you expand this, you'll end up with 3 terms. Take a look. 2 times x squared plus 4x. So far, so good, right? X squared plus 4x, x squared plus 4x. But then we have plus 4, right? So now we have to get rid of this 4. The other side equals negative 1. But take a look at this, because we have a 2 coming from outside, right? This 2, which we factored. So 2 times 4 will increase the value that we need to get rid of. So instead of 4 that we need to get rid of, we're going to have to, because of this 4, we're going to end up with a positive 8 because of this 2. 2 times 4 is 8. So what we need to do is subtract not 4, 8. Okay? That way we don't have to do what I did up here. Because what I did up here, I got rid of the 1 by saying minus 1. But then I noticed, oh, I have a 3 out here. So that 3 is going to multiply this and give me 3. So then I added the curly brace that you see. Because that curly brace means I'm going to have to distribute the 3 into the negative 1 as well as this one. So it would give us the right terms. Here, remembering that I have a 2 out here that is going to multiply this third term that we didn't need to begin with. So 2 times 4 is 8. So it's really, we need to subtract 8 from this in order to end up with just 2 times x squared plus 4x, which is what we had up here. Okay? All right. So now, let's solve. So we have, now that I'm writing this blue one. The blue ink that you see is just to show you why we're subtracting what we're subtracting. That's all. But you don't have to write this. Once you're at this stage, you should know what you have to subtract and proceed from there. So this step is unnecessary, but I've done it so you all see why we're subtracting negative 8 and why we're subtracting negative 1 here. So then, but we could have jumped from here to this step, which is 2 times x plus 2 squared equals, then I should have put minus 8 there, but it's okay. This shows you why we need the minus 8. And now move the negative 8 to the other side. Negative 1 plus 8. Okay. And then we end up with positive 7. So 2 times x plus 2 squared equals positive 7. Then we're solving for x, right? So we've completed the square. Now we're solving for x. And completing the square, what it did was, before we completed the square, we had x in 2 locations, right? After completing the square, we have x in 1 location. So x has been isolated more than before applying the completing of the square method. So then x plus 2 squared is equal to 7 over 2, right? I divided both sides by 2. That's what we end up with. And then let's take the square root of both sides. So we have square root of x plus 2 squared equals plus or minus square root of 7/2, right? So we end up with, by the square root property, remember that square root property, this one, we end up with x squared equal to anything, taking the square root of both sides, we end up with x equals plus or minus square root of c. And that's what we have, plus or minus that. And the left side will be just x plus 2 equals plus or minus square root of 7/2, right? So we can rationalize this if you want. Let's do that. So we end up with x plus 2 equals plus or minus square root of 7 over square root of 2. So we're going to break it up. And then we're going to rationalize this by multiplying both the numerator and denominator by square root of 2. So square root of 2 times square root of 7. That'll be a square root of 14 divided by square root of 2. So x plus 2 equals plus or minus square root of 14/2, right? After multiplying both the numerator and the denominator by square root of 2. We've talked about rationalizing the denominator, right? So now I can just move the positive 2 to the right-hand side. So x equals minus 2. When we move this to the other side, it becomes minus 2 plus or minus square root of 14/2. Like that. Okay, I hope this is making sense, and it occurs to me that I didn't leave much room in these worksheets for these solutions. So let me put a line there to separate the solution for the problem above than the solution for this problem. Okay. So here we want to solve the equations. Again, for all of these, please pause the video and solve each equation on your own, and then unpause the video and see what I'm doing. Okay, so in this case, we have just a simple linear equation. So from here, we have 8x. Move the -9 to the other side to isolate the term that has x in it, right? So that'll be 4 plus 9. Then it'll be 8x equals 13. And then therefore x is equal to 13 divided by 8. Okay. A fraction. Nobody likes the fraction, right? Neither do I. So let's get rid of it. How do we get rid of the fraction? Well, we'll multiply the equation by a single term that would clear all fractions at once. Not one by one, but all fractions at once. In this case, fortunately, we just have one fraction. So we'll multiply both sides by the term that would get rid of the fraction on both sides. So that times 1/3 x minus 2 equals 3 times 1. Okay, so let's distribute, then simplify. You do not want to distribute and simplify at the same time, because I've seen it many times, it generates errors. So let's distribute, then simplify. So we have 3 times 1/3 x minus 3 times, right? We distribute the 3 into all the terms, times 2 equals, the right side is okay. We can just write down 3. Okay, so now what do we have? Let's simplify. We did distributing, now we're simplifying. So this 3 and this 3 cancel out. we get x. Minus 6 equals 3 on the other side. So x equals, send the negative 6 to the other side, it becomes positive 6, gets added to 3, and we have x equals 9. Okay? Are you doing this before you watch the video? If you're doing it, awesome. You're doing great. So this next one, I hope you're solving this before you watch the video. Okay, so in this case, we have a simple linear equation. We're solving for t, it's the only variable. To do that, let's isolate all the terms that have t in them. So we have a 15t here. Then we have a minus 15t here on the other side. Bring that minus 15t to the left, and that will cause this coefficient to become positive 15t equals, then we have a 10 on the other side. We have a negative 10 on the left. Move this negative 10 from the left to the right, and we end up with positive 10. So what do we end up with? We have 30t equals 20, and then t is equal to 20 divided by 30, or 2/3, right? 2/3. Okay, so this one, part D, we have two fractions. So we need to multiply both sides of this equation by a single digit that would get rid of both fractions at once. So you do not want to multiply the left by 2 and multiply the right side by 4. That would be totally wrong. I've seen people do that many, many times. Please do not do that. Multiply both sides by a single digit that would clear both fractions at once. What number would that be? If you answered 4, excellent, you are right. So 4 times 1/2 y minus 5 equals 4 times 1/4 y, right? So what I'm asking you guys to do is don't distribute and simplify at the same time. I've seen it generate many, many errors in your calculations. So first distribute, then simplify, which is exactly what I'm going to do. So 4 times 1/2 y minus 4 times 5, right? And of course, on the right side, you have that. You can simplify that because it's just one term left anyway. So the 4 and the 4 cancel each other out, so we end up with y. Okay, so on the left, now let's cancel things that can be canceled. This 2 goes away, we end up with 1. This 4 goes away, we end up with 2, right? This 2 in the denominator is a factor of 4. So we end up with 2y minus 20, right, equals y. And we've been able to, by multiplying both sides by 4, we've been able to get rid of both fractions at once. So now, because we're solving for y, we need to isolate y. So let's do that up here. 2y, I'm going to bring the y from the right to the left. It was positive on the right. When I move it to the left side of the equality symbol, it changes algebraic sign to its opposite, from positive to negative. Equals, I have a negative 20 on the left. When I move it to the right, it's going to be positive 20. So we have y, 2y minus y is y, equals 20. Like that. Okay, so this next equation, we have numbers outside of each parenthesis. Well, in order to solve x, we need to isolate it. But how can we isolate it if x is part of a group defined by the parentheses? So we have to ungroup x. It's the same once we get to absolute value equations. You'll see we'll have to get rid of the absolute value in order to solve for x. Why is that? Because parentheses and absolute values and even fractions are grouping symbols. They group terms. So I mean, take a look at, we're going to take a look at this next, but ahead of time, take a look at this. This fraction groups the terms x minus 1. This fraction groups x plus 1. It puts the x plus 1 in a group. This fraction groups x squared minus 1. The same way parentheses groups whatever it's in it. So does the absolute value. So when you solve for something like this, you have to first ungroup x by distributing the number that is in front of it. If you can't ungroup it, or if you don't ungroup it, you can ungroup it, but if you don't, you're not going to be able to isolate x. The same way here. So the first thing is get rid of the grouping symbol, which is the fraction line. That's why we clear, when next we solve for x, you'll see the first thing we'll do is clear all the fractions. Why? Because fractions are grouping x with other terms. We can't have that. That's why we need to get rid of the fractions to ungroup x. So here, to ungroup x, we're going to need to distribute the numbers that are in front of the parentheses on each side. So we have 3 minus 3x equals 8 plus 16x, right? Distribute to each, plus 2. Okay, so now let's put anything that has x in it on the left, anything that is a constant on the right. And that's my habit. Every time I'm solving for x or any variable, I put that term on the left, not on the right. That's what I prefer. So minus 3x, we have a positive 16x on the other side. Let's move it to the left. So minus 16x equals 8 plus 2. So we have a positive constant 3 on this side. Move it to the other side. It'll be minus 3. Okay, so let's simplify. We have minus 19x equals 10 minus 3, that's 7. So x is equal to minus 7 over 19. And that isolates, dividing by minus 19, isolates x by itself. Okay, I'm just going to double check this for a second. Everything looks good, but just double checking. Okay. Yep, it looks good. All right. So this one. Now, this fraction line in each of these fractions is grouping x with something else. It's grouping x with 1 here. It's grouping x with negative 1. It's grouping x squared and minus 1. We need to ungroup this by multiplying both sides of this fraction by a single term that would clear all three fractions at once, not one by one. To do that, let's figure out let's factor out this denominator. If you do that, this is what we end up with. So 1 over x minus 1 plus 2 over x plus 1 equals 4 times x plus 1 times x minus 1. We need to find the factors because we need to find what are the terms or the term by which we can multiply both sides of the fraction and get rid of all the fractions at once. And factoring allows us to see that. So x plus 1 times x minus 1, x plus 1, x minus 1. Great. So if we multiply both sides by x plus 1 times x minus 1, we'll be able to get rid of all fractions, all three fractions at once. So let's do that. So we have x plus 1. I hope I'll have enough space here to put all the solution. I'll try to fit the solution here. Multiplied by the left-hand side, 1 over x minus 1 plus 2 over x plus 1 equals x plus 1 times x minus 1 times 4 over x plus 1 times x minus 1. Okay, so let's distribute first, then simplify. Don't do both things at the same time. Don't distribute and simplify at the same time. First distribute, then simplify. So what I mean is this. So x plus 1 times x minus 1 times 1 over x minus 1. There, I've distributed it to the first term. Then plus x plus 1 times x minus 1 times 2 over x plus 1. Then, on the right though, we're okay. We can simplify immediately. Because if you look at what we're multiplying it by what the denominator is, this x plus 1 and that x plus 1 cancel out. This x minus 1 and that x minus 1 cancel out. So we end up with just 4. Okay, so let's simplify on this side. We have x minus 1 and x minus 1 cancel out. X plus 1 times 1 is x plus 1 plus x plus 1 and x plus 1 cancel out. We end up with x minus 1 times 2, or 2 times x minus 1 equals 4. Okay, we have a little more work to do because this is a linear equation. So we have x plus 1. I'm going to distribute this 2 plus 2x minus 2 equals 4. Right? Now 2x plus x is 3x. 1 minus 2 is minus 1. Move it to the other side, it will be positive 1. So 3x equals 5, x equals 5/3. And there we have it. One thing that I haven't been mentioning with respect to this is that when with fractions, with any fraction, when you solve for x, once you get the value for x, make sure that that value of x is not making any of these denominators equals to 0. Because if it does, then the solution you have, even though it's a correct solution, you can't keep it. Because it will generate an undefined solution. So you got to toss out and you will say no solution exists. So whenever you have a fraction, just make sure that the value of x is not making the fraction or the denominator equal to 0. Okay, so this is a quadratic equation. They're not specifying what method. Remember earlier they said solve this quadratic equation using completing the square. When the problem specifies for us to use a specific method, we will do that. But in this case, it's left up to us. So the first thing I would use is factoring because it's the easiest one. If that doesn't work, then I'll go to the quadratic formula and so on. So in this case, this looks like an easy expression to factor. So we can factor this out as x plus 9 times x minus 8 equals 0. Right? X times x is x squared. 9 times minus 8 is minus 72. where's the x term going to come from? It's going to come from multiplying x by minus 8, which will give us minus 8x plus 9x. 9x plus minus 8x is going to give us positive x, which is what we have. Okay, so now remember that property that I showed you, the zero product property. Remember that? Remember this property on page 1? On page 1. If this is the case, if this times that in 2 terms times 2 terms equals 0, then either x minus a should be equal to 0, or x minus b equals to 0, or both x minus a equals x minus b equals 0. We're going to apply the zero product property here to solve for x. And the power of x, which is 2, tells us how many solutions we can have. Right? We must have 2 solutions. And the discriminant, remember when we talked about the discriminant? The discriminant tells us whether we have real solutions and how many, whether we have complex solutions and how many. Right? We talked about the discriminant on the first page. Remember that? This one, the properties of the discriminant. Okay, so here it looks like both solutions are going to be real solutions. So let's solve for them. So x plus 9 equals 0 by zero product property, right? Therefore, x equals minus 9. So that is one solution. Then x minus 8 equals 0. Therefore, x is equal to 8. This one, also, this is an easy quadratic equation to factor. So let's do that. Otherwise, we could use the quadratic formula. So x minus or plus 6 times x minus 1 would be the factorization of that. Right? So x times x is x squared. 6 times minus 1 is minus 6. Where are the 5x term is going to come from? It's going to come from the sum of x times minus 1, which is minus x, plus 6 times x, which is positive 6x, minus x, it gives us positive 5x. So we have it. We have the correct factorization. So let's use the zero product property to solve for x. X plus 6 equals 0, therefore x equals minus 6. X minus 1 equals 0, so x equals 1. Okay. This one also looks like an easy equation to factor. Let's see. So if I have 4x squared, I could have 2x and 2x times each other, but that wouldn't work for the middle term. So let's try this. Let's try 4x times x. So that's going to give me 4x squared. And to get minus 3 and minus 4x, I'm going to put a minus 1 here and a positive 3 here, and I think that should do it. Because 4x times x is 4x squared. 4x, or 3 times minus 1, minus 3. The middle term is always the last term we have to investigate. So where is the minus 4x can come from? It can come from, no, it didn't actually. Let's see. Looks like, so minus 4x plus, so that's not minus x. For a second I saw that as minus x, so no. So let's see. If I have 2x, let's use a scratch paper. I might have to use the quadratic formula. Let's see. So let's see what the discriminant says. So the discriminant is b squared minus 4ac, right? So here, A is 4, B is minus 4, and C is equal to minus 3. So putting that in the discriminant, we have minus 4 squared minus 4 times A, which is 4 times C, which is minus C. What do we get? We get positive 16, positive 48, right? 16 times 48, and we get 14 and 64. No, we should be able, that's a perfect square. So 6, right? That's a perfect square. So we should be able to factor this. Let's see the correct factorization of this though. But this, we can factor it, but this is not the correct factorization. So let's see what is then. If I put 2x and 2x, then that would be, yeah, that would be 2x and 2x. It would work if we go with that. Let me correct then. So I'm going to use my thicker marker to make this, well, let's do this on a piece of scratch paper first. So the 2x and 2x would work, but let's see. So 2x equals 0. And then if I put minus 3 here and a plus 1 here, it would work, yeah. So because it would work because 2x times 2x, 4x squared. 1 times minus 3, minus 3. How about the middle term, minus 4x? How can we get that? We can get that from these two. From 2x times minus 3, which would be minus 6x, and multiplying these two, positive 2x. Minus 6x plus 2x is minus 4x, right? So this is the correct factorization, not the one I have. So let me correct that. We have 2x here and 2x here, and then plus 1 here, plus 1 here, and minus 3 here. Okay, like that. Okay, so now let's use the zero product property to set each factor to 0 and solve for x. So 2x minus 3 equals 0. We have 2x equals 3. We have x equals 3 halves. That's one of the solutions. Let's set this factor equal to 0. We have 2x equals negative 1. X equals minus 1 half. Okay. All right. So another one, part J. So let's see, how can we factor this? 3y and y will give us the 3y squared. Then, okay, so this is easier than to factor. So 3y times y, it's going to give us y squared. How are we going to get 4 as the product of two terms such that the y terms add up to 13y? So if I put a 4 here, that is going to give me the y terms. 3y times 4 is 12y, and I need a 1y, which is 1 here, times y, it's going to give me 13y. 1 times 4 is 4, so it'll work out. Okay, so let's put each factor equal to 0 and solve for y. So 3y plus 1 equals to 0. Y equals minus 1/3. Again, we're using this property, guys. We're using on page 1 of the worksheet for section work fine 1.5, we're using this property, the zero product property, with two terms in a factor. Two factors, two terms in each factor. If that's equal to 0, then either this is equal to 0, we're doing that, And then we're doing that to solve for x. Okay? And then for y plus 4 equals 0. So y equals minus 4. Okay, this one, it is another quadratic equation. Can we factor this looking at, let's see, yeah, it can be factored. So x times x is going to give us x squared. What two terms multiply to negative 8 and add up to minus 2? Well, that would be minus 4 and positive 2, right? X times x, x squared. 2 times minus 4, minus 8. Where are the x terms are going to come from? They're going to come from these two, x times minus 4, minus 4x, plus 2 times x, minus 4x, plus 2x is going to give us minus 2x, right? So we have it. So we have the correct factorization. So by zero product property, let's set each factor equal to 0 and solve for x. Like that. Okay. All right. So now you see how useful it is to be able to factor things. So it's worth the practice. Any additional practice that you can get, it's really helpful and makes things easier for you during the homework, during the exams as well. Okay, so we have another quadratic equation here. Let's see if we can factor this. So what two numbers add up to or multiply to minus 9 and add up to positive 7? Let's see. If I have, I'm going to grab a piece of scratch paper here and find the factors. So 2x squared, we have no choice but to take that as 2x times x, right? That's going to give us the 2x squared. The minus 9, I can have a, if I put a minus 1 here and or a positive 9 here, would that work? Looks like, well, if I put a plus 1 here and or a positive 9 here and minus 1 here, I think it'll work, yeah. So 2x times x is 2x squared, right? That's what we have. Then 9 times minus 1, it's minus 9. That's what we have. How about 7x? Where is the 7x going to come from? Well, the 7x is going to come from multiplying 2x by minus 1. That'll be minus 2x plus 9x plus 9x. So add these two, you get positive 7x. So we get 2x squared positive 7x minus 9 equals to 0, which is what we have. So this is the correct factorization. Okay, so I'm going to write that down. So we have 2x plus 9 times x minus 1 equals 0. Okay, so let's set each factor equal to 0 and solve for x. That's one solution for x. So if we had a fraction of some kind and x was in fraction, I would make sure that that value of x is not making the fraction denominator equal to 0. So just remember that, please. So x minus 1. I'm asking you to remember this because in the future we will use that. It will come in handy. So x equals 1. Okay. Okay, so now we get to expressions that have one radical expression in them. So the question is, how do we solve for x when we have radical expressions? One thing is, radical expression is also a grouping symbol. So anything that is under, any variable x that is under a radical expression, you want to do something to bring it out. Because as long as this x is inside the radical, you cannot solve for it. You need to ungroup it from the square root symbol or operation. Okay, to do that, first thing, isolate the radical expression, the one radical expression on one side. So note isolate the only radical expression on one side of the equation. So that means we need to do this. So that means I need to move the plus 1 to the other side and make it negative 1. So square root of 2x plus 1 equals x minus 1. So we isolated the radical expression on one side by itself. Okay? So now square both sides. So square root of 2x plus 1 squared equals x minus 1 squared. So now on the left, things are becoming very easy, right? This 2 and the index, which are equal, index of this root, which are equal to each other, they cancel each other out. So we get 2x plus 1 equals that. So let's expand that, because again, we have parentheses around that. That's not going to let us solve for x. So let's expand that using either, you can either FOIL it or use the use the special product formulas that we talked about in the last class. Okay, so I'm going to do that because it's quicker and easier, like that. So now we're solving for x, right? And this is now emerging as a quadratic equation. So let's move everything to one side and set the equation equal to 0. I'm going to move this to this side. So all of these terms maintain their algebraic sign as you see them. So positive x squared minus 2x plus 1. Now I'm going to move this to the other side. 2x becomes minus 2x, plus 1 becomes minus 1, equals 0. Like I said, I have a habit of collecting everything on the left when I solve equations, the variable terms. Okay, so let's simplify this. We have x squared minus 4x, and positive 1 and negative 1 cancel out. We end up with that, right? So now we can factor x. X times x minus 4 equals 0. Then by zero product property, then x should be equal to 0. If we have two terms that multiply to give us 0, then either this is 0 or that is 0. So let's find out for x there. X equals 4. Now we have two values of x. Should we accept these? Not here. When you're solving a radical expression, an equation that has a radical expression in it, once you find your solution, you must check back and see if these solutions actually work. If they don't work, or anyone, if they both work, then you accept both. But if one or the other doesn't work, as you plug them in, you must toss out the solution that you found. So there's nothing wrong with this process. These solutions are okay, but we have to check them. If they don't check out, we toss them out. So so you can barely see this. So we have to check. Let me write it here because you can't see it on the screen. So checking in this equation, 2x plus 1 equals x, right? Checking that. Checking both of these solutions in that. We're going to do that. So check x equals 0. Let's do that first. We're going to plug in whatever you see x with 0. So 2 times 0 plus 1 equals 0. So this is square root of 1, right, which is 1, plus 1 equals 0. 2 equals 0. Is that possible? Not possible, right? Not possible. So we need to toss out x equals 0. Let's toss it out. Next, not possible. Toss out x equals 0, which I did right here. Now check x equals 4. So square root of 2 times 4, I'm just plugging in there, plus 1 equals 4. So this is 2 times 4 is 8, 8 plus 1 is 9, square root of 9 is 3 plus 1 equals 4. So 4 equals 4, that checks out. So this solution is okay. X equals 4 is okay, x equals 0 is not. Okay, so we accept only one solution there. Okay. So here we have two radical expressions, one embedded into another one. In fact, it doesn't matter if it was embedded or not, but what we have is more than one radical expression. That's what that should catch your eye, that instead of one radical we have two. So what do we do now? Well, here we have to do what we did on the previous example at least twice. Once to get rid of one time to get rid of one of the radical expressions, a second time to get rid of the second radical expression. So let's do that. So everything is under the radical expression, so I'm going to square both sides as you see it. So I'm going to say square root of x minus 5 plus x. That x is outside of this one, right? All of that squared equals 5 squared. So what this does, it's going to get rid of the big radical expression. So on the left, what we'll end up with is square root of x minus 5 plus x equals 25. Okay, so now we've reduced that to two radical expressions to one. Okay, so actually this isn't the most complicated expression like this. There are ones that it takes a while before you get rid of one radical, and then you'll have to get rid of the other radical expression. Like I said, we have to get rid of the radical expressions because radical expressions like parentheses, like absolute value, like fraction lines, these are grouping symbols. They group x variable with something else. But if we're solving for x, we cannot have it grouped with something else because we want to isolate it. Okay, that's why we need to get rid of the radical expression. So now, just like the previous example, we end up with one radical expression, and we need to isolate that radical expression by itself on one side of the equation. So what we will do is square root of x minus 5 equals 25 or x, 25 minus x. Okay, let's move the x to the other side. Now we square both sides again to get rid of this one. So we have square root of x minus 5 squared equals 25 minus x squared. On the left, things become very easy because this 2 cancels out the, which is equal to the index or root of the square root. So they cancel each other out. The index of this radical expression is equal to this power. So x minus 5. On the other side, I think I'm going to need my calculator here. So what is 25 squared? Right? So 25 squared is 625. So 625 minus 50x and plus x squared. So this is a quadratic equation once again. Let's move, because the coefficient of the quadratic term is positive on that side, I'm going to keep everything on that side and move these two with them. So notice as I do that, all these algebraic signs stay as they are. So x squared is positive, minus 50x, and positive 625. Now I'm going to move these two to the same side as them. So x is positive. When I move it, it becomes negative x. Minus 5 is positive, negative. So when I move it to this side, it becomes positive 5 equals 0. Okay. All right, so let's simplify this a little more. X squared minus 51x plus 630 equals 0. Okay, it turned out to be a big expression here. So I'm going to use, because factors are not immediately clear to me at all. So what I'm going to do is, well, let's see if 630, let's just take a wild guess. 630 divided by 51. No, so no help at all on that. So I'm going to use the quadratic formula. So we have x equals minus b plus or minus square root of b squared minus 4ac over 2a. So this inside b squared minus 4ac is called the discriminant, right? And we talked about the properties on the front page. So here a is 1, b is negative 51, and c is equal to 630. So let's plug in. We have x equals minus b or minus 51 plus or minus square root of b squared, which would be minus 51 squared, right? Minus 4 times a, which is 1, times c, which is 630. All of that over 2a, which is 2. 2 times 1, which is 2. Okay, so x equals 51 plus or minus. Let's see what do we get here. I'm going to need my calculator. Let me see if I can put everything on the screen here. Yep, that should be good. So we have 51 squared, which is 2,601, minus 4 times 630. So 2,520 divided by 2, right? So now let's take this one step further. We get x equals 51. So minus 51 made this a positive 51, right? So let's see. 2,601 minus 2,520. We get 81. Oh, that's nice, because that's a perfect square divided by 2, right? So what do we have here? Let me, so I think, because I'll need all this blank space here, so let me use up this space before I go up there. So this will be x equals 51 plus or minus 9 divided by 2, right? Okay, so 1x is equal to 51 plus 9 over 2. Another x is equal to 51 minus 9 over 2. So this will be 60 divided by 2. So x equals 30, right? Here, 51 minus 9, that'll be 42 positive 42 divided by 2, which is 21, right? So let me just make sure. 42 divided, it should be 21, yes. So here x is equal to 21. So we have two solutions here, but we cannot accept these right away. We need to check and test these. So let's test them one by one. So I'm going to write this here so we can, maybe here, yeah. So check with the equation that we have, square root of x minus 5 plus x equals 5. We want to plug these two numbers into that and see if the two sides are equal. So check x equals 30. So if we 30 minus 5 is 25. Square root of 25 is 5 plus 30. That would be a square root of 35. Square root of 35 is not 5 for sure. So we should toss out that. Check 30 and we end up with square root of 35 equals 5. Not possible. Not possible, so toss out x equals 30. That one is not acceptable. So let's plug in 21. 21 minus 5, that's positive 16. Square root of 16 is 4. Plus 21, that's square root of 25 equals 5. That's acceptable. So check x equals 21. And now check that, and we end up with square root of 25 equals 5. So if you plug in there with 21, you're going to get this, right? So which is 5 equals 5, so it checks out. So that one, this one is the only acceptable solution, like that. Okay. All right. So here we have two radical expressions, and they're separate. They're not like this one where we had one inside the other, right? This one was one inside the other. We have two radical expressions that are separate. But the idea is the same. You have to isolate the radical expressions from each other. Previously, when we had only one radical expression, we isolated the only radical expression on one side, and everything else was on the other side, right? When you have two, you want to make sure that each radical expression is on a different side of the equation. So I'm going to move this square root of x to the other side. So note, such as this, make sure that right now they're on both sides, they're on the same side, right? We cannot have that. So make sure that the radical expressions are on different sides, or are on the opposite sides of the equation, on different sides of the equation. So that means we have to do the following. So square root of 2x plus 1 equals 1 minus square root of x. Now square both sides. That will get rid of one of these, but keeps the other one, and then you can get rid of the other one second after that. So let's square both sides. Square root of 2x plus 1 squared equals 1 minus square root of x squared. On the left, we end up with 2x plus 1. On the right, we end up with, you can either FOIL this or use if you remember the special product formulas, you can make this a little bit easier on yourself and quickly get the answer. So you can get 1 minus 2 square root of x and plus x. Okay, so now that we went from two radical expressions to one, let's isolate the only radical expression we have and then square both sides again. So let me move everything to the left and simplify, and then we'll square both sides again. So I'm going to move this to the left. So 2 square root of x, now it was negative, now it's positive. I'm going to put everything else on the other side. The 1 plus x, I'm going to keep on that side. Then I'm going to move these two to the other side. 2x becomes minus 2x, positive 1 becomes minus 1. So simplifying, we have 2 square root of x equals 1 and minus 1 add up to 0, right? These two add up to 0. Minus 2x and x add up to minus x. So now square both sides again. Right? So then on the left side, things are very simple now. 2 squared is 4. Square root of x squared is x. On the right, we have minus drops out because this is even power, and then x squared. So what do we have? Let's move the 4x to this side. X squared minus 4x equals 0. Factor the x out. X minus 4 equals 0. Then x equals 0. That's one solution. And x minus 4 equals 0. Therefore, x equals 4. That's a second solution. We cannot accept these two right away. We have to check them. Okay? So check the solutions. with the original equation that we had, which is, I'm going to write it here because it's off the screen, equals 1. Okay, so check x equals 0 to see if it is a valid solution. So we end up with, put x equals 0 here, square root of 2 times 0 is 0, square root of 1 is 1, plus square root of 0 is 0, 1 plus 0 is 1. So 1 plus 0 is 1, 1 equals 1, so it checks out. This checks out. So we know that solution is good, that one. Okay. Then check x equals 4. So we have square root of 2 times 4 is 8, plus 1 is 9, square root of 9 is 3. Right? So 3 plus square root of 4 equals 1. Square root of 4 is 2. So 5 equals 1. Right? This is impossible. Impossible. Toss out x equals 4. So that one, this solution, we toss it out. So the only valid solution is x equals 0. Okay. So here it says, use the quadratic formula to solve the following quadratic equations. Okay, so the quadratic formula, as we know it, it is x equals minus b plus or minus square root of b squared minus 4ac over 2a. And of course, we saw that here on the front page, right? That was that. So in this case, a is 1, which is the coefficient of the quadratic term, b is minus a, and c is equal to 9. So applying the quadratic formula, we have x equals minus b, right? Applying that. So minus 8 plus or minus square root of b squared minus 4 times 1 times 9 over 2a. So 2 times 1, right? Okay, so we have x equals positive 8 minus 8 is positive 8 plus or minus 64 minus 36. What is that? So 64, it is 28, isn't it? So let's see. Let me make sure. 64 minus 36, 28. Divided by 2. Okay, so this is 28 is 4 times 7. So 4 can come out and become 2 times square root of 7. Right? So this is x is equal to 8 plus or minus square root of 4 times 7 divided by 2. I'll try to fit my solution on this page. Hopefully it'll fit. So 4 is 2 squared. So we end up with x equals plus or x equals 8 plus or minus 2 square root of 7 divided by 2. 2 can get factored out. So we can factor that out, times 4 plus or minus square root of 7 divided by 2, right? Then 2 and 2 cancel out, and we end up with x equals 4 plus or minus square root of 7. Okay, so that's that. Here again, we have a equals 1, b equals minus 12, c equals 18, right? So let's plug into the quadratic formula. We have x equals minus b, or minus 12, plus or minus square root of b squared, or minus 12 squared, minus 4 times a times c. And all of that over 2 times a, or 2. Okay, so we have minus 12 is positive 12, plus or minus. What do we get here? We get minus 12 squared is positive 144, minus 4 times 1 times 18, that's 72. So 144, 144 minus 72, we got 72, right? So 72 divided by 2. Okay, so 72 is 9 times 8, and 9 can be written as 3 squared. So x equals 12 plus or minus 9 times 8 divided by 2. And let me come up here to put the rest of the solution. So 9 is 3 squared, so 3 can come out, and this can become 3 times square root of 8. And also 2 and 8 can be written, well, let me write it, so I don't want to just say it. So x equals 12 plus square root of 3 squared times 2 squared times 2. 8 is 2 squared times 2 divided by 2. So we have x equals 12 plus or minus. This 3 can come out, and this 2 can come out. It becomes 2 times 3, 6, square root of 2 over 2. Right? So 6 can be factored out. And 2 plus or minus square root of 2 divided by 2. And then 2 can drop out, we get 1. And this 6 goes away, we get 3, right? Because 2 is a factor of 6. So then we have x. I'm almost out of room here. I'm into this. So we have 3 times 2 plus or minus square root of 2. And that's the final solution. Like that. Okay, it barely fit. Okay. All right, so this one, I don't have much room for that, but let's see how much how much of the solution I can fit in there. If I can't fit the whole solution, I'll just summarize it. I'll put the final answer here. So here, A is 1, B is negative 10, C is equal to 22. So x equals minus b. So let me summarize the solution a little bit. Maybe I can fit it that way. So minus 10 is positive 10, plus or minus b squared would be 100 minus 4ac, that would be minus 88. So 100 minus 88, it'll be 12, right? So 12 divided by 2. So I kind of made this solution a little bit compact. I hope that's okay because I have little space here. But this is just, we're plugging into the quadratic formula with these values for A, B, and C. Okay, let me double check one more time. Minus 4A, yes, that's okay. Okay, so now 12 can be written as 4 times 3, right? 10 plus 4 times 3 over 2. So 4 is 2 squared, so 2 can come out. So we have 2 square root of 3 over 2. Then 2 can be factored out from the numerator. We have 5 plus or minus square root of 3 over 2. Then we can cancel out the 2's. We end up with x equals 5 plus or minus square root of 3. Like that. Okay, so we have 2 solutions in each case. That makes sense because this is a quadratic formula. A quadratic formula, x's highest power is 2, which suggests that we have 2 solutions. But in this case, we have all of these had 2 real solutions. Sometimes you might have both complex solutions. Sometimes you might have 1 real solution and 1 complex, and so on. Okay, the other method that, did I write this on the front page? Looks like I forgot to write this. I'm talking about this page. One of the methods that we're going to apply now is using the method of substitution. I don't see it here. So yes, let me add that. That way when I post these notes on Canvas, they're complete. So in addition to this 10, let me add solving equations using the U substitution. This is what it's called, substitution method. It's an extremely useful method, and you'll see this a lot in Calculus 2 and 3 and beyond. So those of you who have those math courses in your study program, you definitely want to make use of this. It'll make many difficult problems very easy to solve. Very helpful, very useful method. So use substitution to solve the following equations. So here we have x to the 4, which suggests 4 is the highest power of x. So which suggests that we have 4 solutions. So as it is now, this is a difficult equations to solve, all 4 roots. We can find rational roots and irrational roots and all of that, but that can get time consuming. But a very efficient way is use the substitution or U substitution method. So we say let U, I say U because in most books they use U as the letter in this method. I mean, it makes no difference. You can use any letter whatsoever, but in most books they use U. So I'll use that, and it's called U substitution method. So let U be x squared. So you let U be the variable that is attached to B, right? A, B, C, so attached to B. All right. Now replace in the original equation with U representing x squared. So therefore, that means instead of x to the 4 power, we have u squared. Okay? If u is x squared, then x squared squared is x to the 4. Minus 5u plus 4 equals 0. So take a look at this compared with that. Now you have a very easily factorable quadratic equation. So let's factor it. We have u minus 4 times u minus 1 equals 0. Then let's set each factor equal to 0 and solve for u. So u minus 4 equal to 0. That means u equals 4. U minus 1 equal to 0. That means u equals 1. Right? But we're not looking for u. We were looking for x. Right? So let's plug these back into this in order to solve for x. So if u equals 4, then we're going to plug 4 here. 4 equals x squared. Therefore, x squared, x is equal to plus or minus 2. That's 2 of the solutions, plus or minus 2. If u equals 1, then let's plug in for u with 1 in this equation. Then 1 equals x squared. Therefore, x equals plus or minus 1. Look how easy that made, this u substitution method made solving this polynomial, which is to the 4th power. So very quickly we were able to solve this polynomial and we found all 4 solutions very quickly. Okay. Okay, these pages are stuck together. Okay, so we have, again, this equation. You could solve this using the method that we did for solving equations that have a radical expression in them. You can do that, but here they specify that we should use the substitution method. So let's do that. So here we will let u be the coefficient or the coefficient, the b term, or the x term, or the middle term, whatever you want to call it. So let u be square root of x. Okay. Now we're going to substitute back in the equation with u instead of x. So if u is equal to square root of x, then x must be u squared. So u squared minus 11u plus 24 equals 0. Okay. So now, is this something easily? Yes, this is very easily factorable, right? So u times u is u squared. Minus 3 and minus 8 would be the digits here, because minus 3 times minus 8, positive 24. And the u terms are minus 8u plus minus 3u, which will give us minus 11u. Okay, so let's set each factor equal to 0 and solve for u like that. Positive 8. So we're not looking for u, right? We're looking for x. So if u is equal to 3, then let's substitute in this equation. we have 8 equals square root of x. That means to solve for x, square both sides. So x is equal to 64. There's that. And then if u equals 8, then substituting there, we have, what did I do? Sorry. Sorry about that. So let's make this 8. If u is equal to 8, sorry about that. That's what I meant to do. So if u equals 8 here, then we substituted 8, and then x equals 64. So if u is equal to 3, like that, then, so we have 3 equals square root of x, which means x equals 9. So let's, just to be sure, let's check these. Let's check both of these in here. So if we put 64, or 64 in here, 64 minus 64, that would be, let me bring my scratch paper here. We're going to have to check both of these. So let's see. So check x equals 64. So we have 64 minus 11 times 8 plus 24. Is that equal to 0? So this is 64 minus 88, and minus 88 plus 64, it is minus 24, and so minus 24 plus 24 is 0, yes. So check x equals 9, right? It was 9, right? Yes, x equals 9. So x equals 64 worked. Plugging in 9, we have minus, square root of 9 is 3. 3 times minus 11 is minus 33 plus 24. Is that equal to 0? Yes. So in both cases, it checked out. So we checked. Okay. So now we get to another grouping symbol, absolute value, right? We talked about how to solve x for x when we have rational expressions where the fraction line groups x with other terms. So we had to eliminate the fractions before solving for x. We talked about the radical expressions, radical operation or operator is a grouping symbol. So we had to ungroup x from a radical expression by squaring both sides in order to free it so that we can isolate it and solve for it. So in here, we have absolute value that is another grouping symbol. So we need to be able to ungroup this. We need to ungroup x from the absolute value. So one thing you should know, and this goes back to the definition of an absolute value, is that when you ungroup the x term from an absolute value symbol, you're going to end up with two solutions. So one side gets multiplied by -1. So in other words, what I'm saying is that, we're going to remove the absolute value, right? So one of the solutions comes from 9x, the inside of the absolute value without the absolute value symbols, equaling the same number on the other side. So one solution comes from simply removing the absolute value notation. And this goes back to the definition of an absolute value. Okay, so please brush up on that. If you have, just set aside about 5-10 minutes and take a look at that, because this is exactly that. So then the other solution comes from 9x the inside of the absolute value as it is, equal, multiply the other side by -1, -7. So now the absolute value definition, just quickly, so the absolute value definition, this is from the past. I'm just reminding you what is it that I'm using here. Absolute value definition said that if you have some value a or x, then so let's say x, right? Absolute value of x is equal to x if x is greater than or equal to 0, minus x if x is less than 0 or something negative. This is a very, very useful definition of the absolute value. Please look at that, but this is what I'm referring to. So if you want to remove the absolute value, you're going to end up with two situations, and you have to solve for x in each situation. Okay? That's what I'm referring to. All right. So let's solve for x using this. Then x is equal to 7/9. And from here, x equals minus 7/9. Okay. How about this? I do not like to give trick questions on an exam, and I will not do that, but on a worksheet, once in a while, it's not a bad idea. So this is trick question, right? Because absolute value is always positive. When is it going to be equal to a negative number? Never. So this one has no solution. Okay. Now here, this is not a trick question. This one has a solution. And again, applying the definition of an absolute value, which is that one, applying that absolute value definition, okay, applying that, we're going to have two solutions from this. One solution will come from whatever you see exactly without the absolute value. So x minus 3 equals 7. Compare this with that. The only difference is that one has absolute value, this one isn't. So we're going to solve for x. One solution comes from that. The other solution of this equation comes from the absolute value part written without the absolute value symbol, but the other side multiplied by -1, so -7. So now each solution we can then look for from each of these. So this would be x equals 10, right? On that side, this would be x equals minus 4. Okay, so that's how it works. So I mean, let me, for the sake of your notes, let me write using the absolute value definition. I know I put it on the scratch paper, but let me also put it here, that absolute value of x equals x if x is greater than or equal to 0, minus x if x is less than 0. I am not sure, but I think we did talk about this in Math 124, I think. Okay. So with that, we have wrapped up section 1.5. Again, thank you for persisting through this video, and I hope the video is clear and the solutions are clear. And I also hope that as you go through these videos, that first you have downloaded, solved all the problems according to your own current skills, and when you compare your solutions with these ones in the video, I hope your confidence and your knowledge jumps or gets increased exponentially. So that's the way to learn this topic. So please Do not avoid solving these problems on your own first. And make sure you do that first. Read through the sections first. Attempt these problems, the worksheet problems on your own. Then watch the videos. That's my recommendation. Or you can just download the worksheets and watch the video at the same time. But whenever you get to a problem, pause the video, solve the worksheet problem, then continue with the video, back and forth that way. And that's the way to build confidence and increase your knowledge in this course. Okay, for now, have a nice day, and I'll see you all next time.